Look at the image depicted the formation of an ionic compound. You know that an ionic compound is formed by the transfer of electrons. That is, here you can see sodium loses one of its electron and chlorine accepts the same. Thus, a sodium ion which is positively charged and a chlorine ion which is negatively charged is being formed. Now, tell me about the type of bond formed between them. What type of force holds the ions together? You might have learned in your lower classes that positively charged ions are called cations and the negatively charged ions are called anions. A bond is formed between these oppositely charged ions as a result of electrostatic force of attraction. This bond is called the electrovalent bond or the ionic bond. So, in the case of sodium chloride, the sodium ion and the chlorine ion attains the octet electronic configuration. The two oppositely charged ions, that is, the positively charged sodium ion and the negatively charged chlorine ions, approaches each other and are held together by a strong electrostatic force of attraction. This leads to the formation of an ionic bond. But certain factor affects the formation of ionic bond. This can be explained based on the Kossel and Lewis approach. Let us see these factors one by one. This can be explained based on the Kossel and the Lewis approach. Let us see these factors one by one. The first factor is the ease of formation of cation and anion from their respective neutral atoms. And the second one is the arrangement of positive and the negative ions in the ionic solid, that is the lattice. Let us discuss these factors in detail by taking the formation of sodium chloride as an example. In the formation of sodium chloride, sodium becomes sodium ion by losing one of its electron. The amount of energy required to remove an electron from an isolated gaseous atom is called ionization enthalpy. This process is always endothermic in nature. In the same way, chlorine becomes chloride ion by accepting an electron. The amount of energy liberated when an electron is gained by an atom in its gaseous state is called its electron gain enthalpy, represented by delta EgH. The electron gain enthalpy is represented by delta EgH, and it can be exothermic or endothermic in nature. The positively charged sodium ion and the negatively charged chlorine ions thus formed are held together by a strong electrostatic force of attraction and forms sodium chloride. But how will the ionization enthalpy and electron gain enthalpy affect the formation of ionic bonds? Let us see. You know, the formation of cation depends on the magnitude of ionization enthalpy. What if the ionization enthalpy is low for a particular atom? Then it will be easy to remove an electron from the isolated gaseous atom, right? Which means the ease of formation of cation is higher. In the same way, the formation of an anion depends on the magnitude of electron gain enthalpy. Higher negative value of electron gain enthalpy makes the formation of anion easier. So, it can be concluded that the ease of formation of an ionic bond between elements with low ionization enthalpy and element with a high negative value of electron gain enthalpy is greater. So, we were discussing about the factor which affects the formation of an ionic bond. The first one was the ease of formation of cation and anion, which we discussed on the basis of ionization enthalpy and electron gain enthalpy respectively. Now, let us move on to the next factor, that is the arrangement of positive and negative ion in the ionic solid. that is the lattice. In a crystal lattice, the ions are arranged in a three-dimensional way, where the cations and the anions are held together by Coulombic interactions. For example, let us look at the crystal structure of sodium chloride. Here, the oppositely charged ions are arranged in an orderly manner. Note that the structure may vary for other compounds based on the size of an ion present. Now, what about the stability of an ionic compound? As you know, a system is said to be stable if the total enthalpy change is negative, right? So, the stability of ionic compound can be determined by calculating the total enthalpy change. In ionic solid, the sum of electron gain enthalpy and ionization enthalpy can be positive and still the crystal structure may be stable. This is because the process of formation of crystal by the combination of ions is associated with the liberation of energy. So, higher the amount of energy released, higher will be the stability of the ionic compound. For example, in the formation of sodium chloride crystal, the ionization enthalpy for the formation of sodium ion from the sodium is 495.8 kJ per mole. And the electron gain enthalpy for the formation of chloride ion from chlorine is minus 348.7 kJ per mole only. Now, when you look at the sum of two, it is equal to 147.1 kJ per mole, which is positive. But in the formation of crystal lattice of sodium chloride, some amount of energy is released, which is equal to minus 788 kJ per mole. So then, the overall energy released will become a negative value, which makes the crystal lattice more stable. The magnitude of energy which is released during the formation of crystal lattice is called the lattice enthalpy. It is a measurement of strength of an ionic compound. Lattice enthalpy of an ionic solid can also be defined as the energy required to separate 1 mole of a solid ionic compound into gaseous constituent ions. That is, in the case of sodium chloride, the lattice enthalpy is equal to 788 kJ per mole. This means that's about 788 kJ per mole of energy is required to separate 1 mole of solid sodium chloride into 1 mole of gaseous sodium and chlorine ions. So, in this session, we have seen the different conditions for the formation of ionic bonds. Now, what about the properties of such bonds formed? We can discuss it in the next class. Now, let's summarize what we have learned.
Manorama Horizon, learning made simple.